I'm going to discuss IN Stream Gate 2023 Max questions. The question is, choose solution set S corresponding to the system of two equations x minus 2y plus z is equal to 0, x minus z is equal to 0. No, R denotes the set of real numbers. 4 options A, B, C, D given. This is from engineering mathematics from the topic linear algebra, subtopic system of linear equations. Now solution. Before going to find the solution, these are two non-homogeneous equations. Variables, all the three variables x, y, z are in the left side, right hand side 0. Only two equations in three variables. This is a homogeneous system Ax equal to O. Definitely it will have infinitely number of non-trivial or non-zero solutions. Okay. Given equations or given two equations. Are homogeneous equations in three unknowns, that is variables x comma y comma z. Since number of equations less than number of unknowns. Okay, yes, see, two equations, three unknowns. Okay, therefore the system correct, that is Ax equal to O, has infinitely many non-trivial solutions, that is non-zero solutions. They are asking the solution according to the options. Okay. Now let us say this is first equation 1 and the second equation this is 2, or just so this is equation 1, let us see. And this is equation 2. Okay. From 2, we have z is equal to x. Okay. Now substituting from 2, we have z is equal to x. Now 1 implies, what is equation 1? X minus 2y plus z. Okay. So let us say this is 3. X minus 2y, z value is, that is x, 0. Using 3. From this, you will be getting y is equal to x. Let us say 4. So from 3 and 4 implies x is equal to y is equal to z. All the three are same. So there are so many infinite solutions. 1, 1, 1, 2, 2, 2, 0, 0, 0. Homogeneous solution also is there. All 0 satisfies. 0.1, 0.1, 0.1, 0.5, 0.5, 0.5. So this is infinitely solutions. Let us take alpha. All the three unknowns variables equal. So how much equal? Let us say that is alpha. Okay. Now, where alpha is a real number is the solution. Where alpha belongs to real number, comma, is the solution. X is equal to y is equal to z. This is the solution. Okay. Now, we can write this solution, that is xyz, in a column matrix. You know that Ax equal to O, where X is a column matrix, etc. Therefore, the solution set means you know that set of all, this is column matrix X, Y, Z. So can I write like this? Okay. Set means that is XYZ is the solution. So this is now set of all. What is XYZ? Each is equal to alpha. If I in each there's all the variables equal to alpha, so alpha is getting common. I can write this is alpha times 1, 1, 1. Can I write like this? Comma. This alpha is a real number. So that means by giving 1 by 1 real number, you will be getting infinitely many non-trivial solutions. Alpha 1, alpha 2, alpha 0.1, alpha minus 3. You can take alpha is equal to 0 also. 0, 0, 0 is also a solution. So any option? So the first option. Such that or where, comma, whatever the notation is there, it doesn't matter. Square bracket or open bracket. Okay. So accordingly, the solution set is S is equal to set of all alpha such that is set of all alpha into column matrix 1, 1, 1 such that alpha is a real number. Alpha belongs to R. Okay. Which implies S is equal to, I can write. Okay. Because in options it has mentioned the solution set S is equal to. The solution set is S is equal to, here also you can write. Implies S is equal to, finally I can write like that. Okay. So accordingly, answer is option A. This is the end of the question. F of z is equal to 1 upon 1 minus z when expanded as a power series around z is equal to 2 would result in f of z is equal to sigma or summation k is equal to 0 to infinity ak into z minus 2 whole power k, which is a region of convergence ROC mod z minus 2 less than 1. The coefficients ak, comma k greater than or equal to 0 are given by the expression. 4 options given. This is from engineering mathematics, from the topic complex variables, power series, that is Lorentz series, etc. The solution is, here the key point is around z is equal to 2. I already told you around z is equal to a is nothing but in powers of z minus a. Final expansion should containing powers of z minus a. Every term should contain power of z minus 2. So that is, this is one. That's why when you expand, giving by k 0, 1, 2, 3, you will be getting powers of z minus 2 only. This is ROC also given. Now they are asking coefficients ak. Okay. Solution. So to expand, capital F of z is equal to 1 upon 1 minus z around z is equal to 2. That is in powers of z minus 2. We can go by substitution method also. Or we can rearrange the terms of the denominator to get in terms of z minus 2 term. If you get z minus 2 term in the denominator by just adding minus 2 plus 2, then finally comparing with 1 minus z whole power minus 1 standard Maclaurin series expansions, you will be getting the answer. So better way is substitution method, comma, put z minus 2 is equal to t, that is change of variable, to make this expansion in a simpler way. Z is equal to t plus 2. Therefore, your capital F of z now 1 by 1 minus of t plus 2, which is nothing but 1 minus 1 divided by minus t minus 1. Take out minus common. This can be written as minus 1 by 1 plus t. So which is denoted by some small f of t function. It is a new function now. Now shift this denominator to the numerator, will become minus of 1 plus t whole power minus 1. So looks like 1 plus x whole power minus 1 binomial expansions or standard Maclaurin series expansions, 1 minus x plus x square minus etc., where x is real or complex. If mod x less than 1, this is the condition. Now using that, you will be getting here minus of 1 minus t plus t square minus so on. Now this is equal to minus 1 plus t minus t square so on. Now can be put in z minus t is replaced by z minus 2 minus 1 plus of z minus 2 minus of z minus 2 whole square plus so on. All these terms I can write summation k is equal to 0 to infinity ak into z minus 2 whole power k. So that what is ak? Minus 1 whole power k minus 1. So in place of ak, I can write directly alternative symbols. Minus plus can be written as minus 1 whole power k. If you put k 0, the first term is symbol is plus, but it is already minus, so k minus 1. So comparing with summation k is equal to 0 to infinity ak into z minus 2 whole power k, we get ak is equal to minus 1 whole to the power k minus 1. Okay. Is there any options? K minus 1? K minus 1 is not in the option. So minus 1 whole power k plus 1 is same as minus 1 whole power k plus 1 also. Take k is any number 1, 2, 3, etc. So in place of minus I can write because of options plus, and this is also plus. Are you following or not? So this is the comparison. This is the given. And we got, this is summation. This one we got in summation. Finally, this is your AK. And what is the region of convergence in place of C? When this is valid, what is the condition? If mod t less than 1. What is t? Mod z minus 2. So finally, I can write the convergence in this. If mod z minus 2 actually doesn't require to write ROC, it is already mentioned. Just by comparing the procedure I'm writing like this. Finally, the option is B. This is end of the question. Comma t greater than or equal to 0 to the differential equation x double dot is equal to minus k times x dot comma k greater than 0 with initial conditions x of 0 is equal to 1 and x dot 0 is equal to 0 is 4 options given. This is from engineering mathematics, from the topic differential equation subtopic higher order linear differential equation with constant coefficient, that is second derivative. Here x is dependent variable, t is independent variable, solution is x is equal to etc. T is independent variable, initial conditions given. These are the two initial conditions, x value 1, t value 0, x dot, that is dx by dt value 0, t value 0. Whenever the right side 0, the equation is called homogeneous and linear, otherwise non-homogeneous linear. Here one of the term dependent variable on the right side, that is derivative, first derivative. Just write this term in the left side so that right side becomes, then only it is called homogeneous and linear equation whose solution is complementary function only. Differential equation D can be written as 1 dot means first derivative with respect to t, 2 dots means second derivative. Bring all the derivatives including dependent variable on the left side. So d square x by dt square plus k times dx by dt is equal to 0. This is equation 1. Okay. So what is operator form? Where capital is equal to d by dt, I can write after taking x common, d square plus k into d into x is equal to 0. X means x of t. So this is your equation 1. D stands for d by dt. Okay. Now, auxiliary equation. Putting d is equal to m, or you can write d square plus k into d is equal to 0. That is also k into m is equal to 0. M is getting common. M into m plus k equal to 0. From this, m values 0 comma minus k. Comparing with distinct roots. Okay. Just comparing with the nature of the roots m1 comma m2. Okay. Therefore, the solution of equation 1 is x of t is equal to cf, or you can write simply x is equal to cf, where the cf table, if you refer the cf table, in place of x, now we consider the independent variable t, which is equal to two distinct roots m1 m2 means c1 e power m1 t plus c2 e to the power m2 t, because t is independent variable. C1 e power 0 t plus C2 e to the power minus kt. So this e power 0 value 1. Now let us denote this is equation 2. One of the condition dx by dt. This is also denoted by x dot, 1 dot. So derivative with respect to t, C1 derivative 0, C2 into e power minus kt minus k times C2 into e to the power minus kt. This is equation 3. Now using given conditions, x value 1 when t is equal to 0 and x dot value 0 when t is equal to 0, comma Substituting in 2 and 3. 2 and 3 gives x value 1 means here. That is, this is called x of 0. Okay. 1 is equal to C1 e power 0 T0 e power 0 value 1 C1 plus C2. We will be getting 1. And dx by dt, that is x dot t is equal to 0, x dot 0 is given 0. 0 is equal to e power 0 again, t is equal to 0, 1. So minus k C2 from this C2 value 0. Therefore C1 value 1. These are the two fixed constants values, C1 1, I mean arbitrary constants, which are now become fixed constants, C2 0. So therefore x of t in second equation, if you substitute 1 only. Okay, so this is the answer 1. Accordingly the option is C. This is the end of the question. Question is, what is limit extends to 0 f of x comma where f of x is equal to x sine 1 by x? 4 options given. This is from engineering mathematics, from the topic calculus, subtopic limits. So finally this is fx. And they are asking about this limit. Now solution. Limit x tends to 0 f of x is equal to limit x tends to 0 x sine 1 by x. When x is approaching to 0, 1 upon x approaching to infinity. Am I correct or not? Or you can take substitution method also. So this can be written as, put 1 upon x is equal to theta, so that x is equal to 1 upon theta. As x approaches to 0, comma, theta approaches to 1 upon 0, infinity. Now this becomes x variable, change it to theta variable because it is not direct limit, standard limit. Okay, so theta tends to infinity sine theta by theta. So this is a standard limit actually, fourth standard limit in limits formulas. This is giving 0. Since limit x tends to infinity sin x by x or cos x by x or log x by x, all the three terms having answer 0. So the answer is 0. Accordingly the option is A. Or you can evaluate by the procedure, conceptual procedure. Sin values lies between -1 to 1. And using sandwich theorem, that is -1 less than or equal sin theta less than or equal theta, dividing all the three by theta and apply limit theta tends to infinity, you will be getting 0 using sandwich theorem. That is conceptual way procedure. This is problematic approach way. So the answer is 0. This is the end of the question. X is a discrete random variable which takes values 0, 1 and 2. The probabilities of P of x is equal to 0 is 0.25 and P of x is equal to 1 is 0.5. What E of dot, denoting the expectation operator, dot means that number x value. The value of E of x minus E of x square is rounded off to 1 decimal place. Here P of 0, P of 1 given. Am I correct? First of all, three values. P of x is equal to 0 given. P of x is equal to 1 is given. P of x is equal to 2 is not given. Let us start with P of x is equal to 2. So this is finally we are going to find expectation. Solution. Discrete random variable mentioned. These are the key points. Let P of x is equal to 2 is equal to some constant, whatever you like, some k. Sum of all the probabilities equal to 1. X having 3 values. X is equal to 0, 1, since summation P of x, because discrete random variable, our notation is sum of all. In continuous random variable, we have to integrate, is equal to 1. Taken over all x values. X is equal to 0 to, which implies P of 0 plus P of 1 plus P of 2 is equal to 1. So this implies 0.25 plus 0.5 plus k is equal to 1. So 0.75, 1 minus 0.75 is k is equal to 0.25. Okay. Now E of x, because of discrete random variable, mean of the value random variable x, summation x values 0, 1, 2, that is 0 to 2, x times P of x. So this is nothing but 0 into P of 0, 0.25 plus x value 1, 1 into P of 1, 0.5 plus 2 into P of 2, we got 0.25. So this is 0.5 plus 0.5. So expectation of x is 1. Next, E of x square. Summation x is equal to 0 to 2 x square into P of x. Okay. This is 0 square into P of 0, 0.25 plus 1 square into P of 1 is 0.5 plus 2 square into P of 2 is 0.25. So this is 0.5. 2 square value 4 into 0.25 is 1. So 1.5. Therefore, they are asking E of x minus E of x square is equal to 1 minus 1.5 is equal to minus 0.5. Okay. This one. So the answer is minus 0.5. This is end of the question. Z is equal to j times 1 minus z by 1 plus z, where z denotes a complex number and j denotes root minus 1. The inverse function f inverse z maps the real axis to the ABCD's option statements given. This is from engineering mathematics from the topic complex variables. Subtopic basics. So this is the key point, function of z given and j value denotes, this is j is equal to root minus 1. Now finally f inverse z maps the real axis. So you know that mapping is a function from domain to codomain. Domain is real axis, codomain means one of the statement. Okay, that is range also. So we are mapping, function is a function from domain to codomain first of all. Every element in A is associated to unique element in the second set, then it is called a function from A to B. That F elements belongs to the codomain B. That F elements set of all F elements, that is set of all images of the domain elements which are in the codomain B. Set of all images is called range of the function. Now we have to find that is one of the ABCD options. Just from 11th, 10th class statement, function definition. Solutions. So, Z denote a complex number. Let Z is equal to X plus IY. In place of I, we have to denote J. And another complex, W. U plus JV, which is nothing but function of Z also. W is a function of Z. Z and W are two sets of complex variables. For every element Z associated to unique element W, then it is a function of Z is a function of W is a function of Z, denoted by W is equal to U plus JV, F of Z is equal to. Okay. Now, I will show the tree diagram in 10th class like that. The first set containing Z elements, the codomain containing W elements. Okay. This is Z and this is W. Okay. Now, if I connect like this is a mapping, F is a mapping from Z to W. If I connect from W to Z, this is called F inverse mapping. F inverse Z, and this is F of Z. Okay. Now, F of Z maps region in Z plane to a region in W plane. Okay. F inverse Z is a function which maps region in W plane to a region in Z plane. So I can write directly F inverse Z. Actually, F inverse W is the correct notation. Maps a region in W plane, that is UV plane, to a region in Z plane, that is XY plane, where X is real axis, Y is imaginary axis. Here U is real axis, V is imaginary axis in W plane. F of Z maps a region in Z plane to W plane. Okay. Now, what exactly given here? F of Z is equal to given F of Z is equal to J times 1 minus Z divided by 1 plus Z. So substitute the above Z and W here. F of Z is nothing but W or no? So this is nothing but W. And what exactly W? U plus JB. And this is J times 1 minus Z. Z value X plus JY. Divided by 1 plus Z. 1 plus X plus JY. Now, separate the real and imaginary parts. Here 1 minus X inside real part, J into 1 minus X becomes imaginary part, J into J square minus 1. And this minus. Okay. So this I can write Finally, multiply the j with numerator terms, you will be getting minus j square y plus j times 1 minus x whole divided by 1 plus x is real part in the denominator, y is imaginary part in the numerator. I mean denominator. So finally, u plus jv is the left side, and the right side y plus j times 1 minus x divided by 1 plus x plus jy. Am I correct or no? J square value minus 1. Okay. J square value minus 1. Now, whenever denominator containing a complex variable or complex number, conjugate the denominator. So, what is the denominator conjugate? 1 plus x minus jy. This should be multiplied for numerator and denominator. We will be giving y plus j times 1 minus x multiplied by conjugate of the denominator. To write that u plus jv in the standard form of a complex number, we have to do conjugate of the denominator. 1 plus x plus jy whole divided by 1 plus x plus jy multiplied by 1 plus x minus jy. Now this denominator looks like a plus b into a minus b, a square minus b square, and j square value minus 1. Similarly, multiply the numerator, the two brackets, 4 terms, you will be getting 2 terms into 2 terms, totally 4 terms you will be getting. So, first y into, collect the real part, that is the terms not containing j, y into 1 plus x, and here second term into second term, j square value minus 1, so minus of 1 minus x into y. This is real part, and y into this term and second term into first term will be containing j term, take j common, so that y into y square, and in this, from this side 1 minus x into 1 plus x. Okay. So here a small mistake I have done. This is minus actually. Okay. So that y into this and this becomes plus. So y into this minus y square, and from this side 1 minus x into 1 plus x. Okay. Whole divided by 1 plus x whole square plus y square, because j square value minus 1. Now separating into real and imaginary parts, this is y common, 1 plus x, 1 minus x simplifies to 2, so 2y divided by denominator 1 plus x whole square plus y square, this is real part, plus j times numerator. This is 1 minus x square, a square minus b square, 1 minus x square minus y square divided by denominator 1 plus x whole square plus y square. So equating real and imaginary parts, okay, you will be getting u and v. So this is u, and this box, this term is v. Okay. Now region in W plane. What is given in the question? So F inverse Z maps real axis. So region in W plane, that is real axis. So I can write here. Region in W plane is real axis. This is given. So what exactly real axis in W plane? U axis. Okay. This is nothing but U axis, X axis. In jet plane, X axis is the real axis, Y axis is the imaginary axis. In W plane, that is U plus IV plane, U axis is the real axis, V axis is the imaginary axis. Equation of X axis is Y is equal to 0. Similarly, equation of U axis is V is equal to 0. Implies V is equal to 0. Okay. Since in jet plane, comma, real axis is X axis, whose equation is Y is equal to 0. So this is the explanation part. Now when V0, this is V. You will be getting, since V0, the denominator into 0 is also 0. You will be getting simply 1 minus x square minus y square is equal to 0. Finally, you will be getting x square plus y square is equal to 1. XY coordinates means this is a region in jet plane. What is the region here? It is a circle having center 0, 0 and radius 1. Okay. So, which is a unit circle, that is radius 1, in jet plane having center at origin, at the origin. Okay. Therefore, F inverse Z maps the real axis to the unit circle with center at the origin. Actually, F inverse W, that is the notation, maps. I don't know why they have given F inverse Z. F of Z maps jet plane to W plane, region in jet plane to region in W plane. F inverse W maps a region in W plane to jet plane. Notation is not, doesn't matter, concept is important. Maps the real axis to the unit circle with center at the origin. This is the answer. So real axis in W plane, unit circle in jet plane. So unit circle with the center at the origin. So accordingly, the answer is option A. This is the end of the question. The question is, the rank of the matrix A given below is 1. The ratio alpha by beta is dash, rounded off to the nearest integer. A is equal to 3 cross 2 matrix, vertical matrix given. So finally, the ratio alpha by beta and rank is 1 given. These are the key points. Now solution. This is from engineering mathematics from the topic linear algebra, subtopic basics, rank. Rank of the matrix A is equal to 1. This is given. Okay. By the definition of a rank using second condition, first condition is given. When rank of a matrix is smaller, then using the second condition of the rank, every minor of order R plus 1 is 0. That is the determinant of every R plus 1 cross R plus 1 submatrix is 0. That is the determinant of every 2 cross 2 submatrix of A is 0. Okay. Implies determinant of every 2 cross 2 submatrix of matrix A is 0 using second condition of rank definition. Okay, so now we are going to find first alpha beta. This is first two rows is 2 cross 2 matrix submatrix. The first and third row, which is again a 2 cross 2 submatrix. So therefore, determinant 1 4 minus 3 alpha is equal to 0, and determinant 1 4 beta 6 is equal to 0. Will be 0, must be 0, that is. See, this is this one. Submatrix of E. And this is also submatrix of E. Leaving the third row, the first submatrix, leaving the middle row, the second submatrix. Now, determinant ABCD is AD minus BC, so you will be getting alpha plus 7 0 and 6 minus 4 beta 0. From this, alpha is equal to minus 7. From this, beta is equal to 2 by 3, 3 by 2. Okay. Oh, sorry. This is alpha plus 12. 4 into minus 3 minus 12. Minus of minus 12 is plus 12. Which implies alpha by beta minus 12 divided by 3 by 2 means 2 by 3 into 2 by 3 I can write. So this simplifies to minus 8. Okay. Since determinant A, B, C, D is equal to AD minus BC. Not required to write inside the determinant the matrix symbol. Okay. This is default notation. So the answer is minus 8. This is the end of the question. Formed using the integers 3, 4, 5 and 6 with exactly one digit appearing twice. This is from engineering mathematics from the topic probability and statistics basics, that is permutations, combinations, basics of probability. So 5 digit numbers required first of all. Using the digits 3, 4, 5, 6 only with exactly one digit removed, because 5 digit numbers means 5 numbers we require, but already 4 digits only given. That's why condition is exactly one digit appearing twice. So solution is given integers 3, 4, 5, 6. Since only one digit appearing twice, so one digit from 4 digits can be selected in 4 ways. Since exactly one digit appears twice in each of the 5 digit numbers, therefore the number of ways of selecting one digit from the given 4 digits is 4C1 ways. Okay, which is nothing but 4 ways. Now, in each 5-digit numbers, the 2 digits are identical. Okay, since 2 digits are identical, that means repeating twice in each 5-digit numbers. Okay, therefore, the required number of five-digit numbers is, now one digit is repeated twice. So this is a result related to the number of permutations of n objects where 2 objects are alike is n factorial by 2 factorial ways. Okay, the number of permutations of n objects such that A objects are alike of one kind, B objects are alike of second kind can be done in n factorial by A factorial, B factorial, the rest are all distinct. So here one digit is only repeated twice. So 5-digit numbers can be formed in how many ways? 5 factorial ways, because one digit is repeated 2 times. So the required number of 5-digit numbers is 5 factorial by 2 factorial. And which digit is repeated? Either 3 or 4 or 5 or 6. That is 4 ways. So that's why 4 into 5 factorial divided by 2 factorial. So this is the key point. This is the original answer actually, 5 factorial by 2 factorial. But this is how many ways again? 4 ways. Because if only 3 is repeated, then the answer is 5 factorial by 2 factorial. Any one of these digits is repeated. So that's why any one of these digits from 4 digits can be done in 4 ways. So that's why the total number of 5-digit numbers permutations is 4 into 5 factorial by 2 factorial. So finally this simplifies to 5 factorial value 120, 2 factorial value 2. So 4 by 2 is 2. 2 into 120, 240 ways. Okay. So I can give the explanation here. Example. The number of five-digit numbers formed by using 3, 4, 5, 6 is 5 factorial by, that is 3, 3, 2 factorial ways. Okay, or I can write, doesn't require to write ways. Here 3 is repeated. This is repeated twice. Actually 5 digits here, 5 factorial, 1 digit is repeated, that's why divided by that number of factorial. This is permutations with repetitions of n given objects. Okay, not with repetitions. In the given objects already 1 digit is repeated. So what is this answer, you remember? So this is 60 ways, 4 into 60, totally 240 ways. So this is answer 240. This is the end of the question. Consider the real valued function g of x is equal to maximum of set x minus 2 whole square comma minus 2x plus 7 where x belongs to minus infinity comma infinity open interval. The minimum value attained by g of x is. This is from engineering mathematics from the topic calculus subtopic maximum minima. The solution is. So this is the function. Is a variety type of function not given directly x square or x square plus 2x plus 7 like that. Maximum of two functions given. This is the domain. Finally, the question requires minimum value. Take care. Very, very tough problem. Solution. So first of all, to find this maximum of the two functions, each function represents a curve. First, we find the point of intersections of these two curves. That means where these two curves meeting. At what values of x these two curves intersecting. So gx given, there x. At the point of intersection of the curves y is equal to, each function is denoted by y is equal to f of x, x minus 2 whole square and y is equal to minus 2x plus 7. We have, whenever left hand side equal, then RHS values must be equal. X minus 2 whole square is equal to minus 2x plus 7. So a minus b whole square, a square minus 2ab plus b square. This finally simplifies to minus 2x minus 3 is equal to, this is minus 4x plus 2x is equal to 0. Factorization, x square minus 3x plus x minus 3, 0. So x minus 3 into x plus 1 factorizable. From this, x is equal to minus 1 comma 3. So we have to find the corresponding y values, or without finding corresponding y values, because function is one variable function. So now, for all values of real numbers, minus infinity comma infinity, x belongs to minus infinity comma infinity means all real numbers. Now all real numbers can be classified into three categories because of 2 points of intersection. All values of x less than minus 1, all values of x lies between minus 1 and 3, all values of x greater than 3. These are the three parts divide the entire real numbers minus infinity comma infinity. When x less than minus 1, at the same time I can take x greater than 3, or you can discuss separately x greater than 3, comma. So take a value of x less than minus 1. Let us take x is equal to 0. Substitute in each of the curves. Find the bigger value or smaller value, whatever. They are asking maximum. So substitute here. If I take x0, this is 4 and this simplifies to 7. 4 comma 7, maximum of 4 comma 7 is 7. So when x less than minus 1, the maximum of these two functions is minus 2x plus 7. Now coming to x greater than 3. Take a value, any value greater than 3. Let us take x is equal to 4. Substitute here. 4 minus 2 whole square is 4. And minus 2 into 4 plus 7. That is minus 1. So 4 comma minus 1, which is maximum? 4. So that means the corresponding function x minus 2 whole square is maximum when x greater than 3. Okay. So sorry for saying this. X less than minus 1 means we have to take any value less than minus 1. I took x0. 0 is greater than minus 1. Let us take x is equal to minus 2. Substitute here. Minus 2, minus 2, minus 4. Minus 4 whole square is 16. Here put minus 2. Minus 2 into minus 2 plus 4. Plus 4 plus 7, 11. So 16 comma 11, which is maximum 16. So the corresponding function value is x minus 2 whole square is maximum when x less than minus 1. So, comma, the maximum of, in that way, take the particular values of x to decide one of the functions is maximum. maximum of x minus 2 whole square and minus 2x plus 7 is x minus 2 whole square. Okay. Next. When the other values of x minus 1 less than x less than 3, comma, between minus 1 to 3, take any x value. Let us take now x 0. 0 lies between minus 1 and 3 or not? Substitute here. 0 minus 2 whole square is 4. Here minus 2 into 0 plus 7 is 7. 4 comma 7, which is maximum 7. So the corresponding function is maximum. Now minus 2x plus 7 is maximum. Comma, the maximum of x minus 2 whole square and minus 2x plus 7 is minus 2x plus 7. What about when x is equal to minus 1, x is equal to 3? When I put x is equal to minus 1, this is 9 and this is 9. Both are same. When I put x is equal to 3, 3 minus 2 whole square 1, minus 2 into 3 plus 7, 7 minus 6 1. So both are same functions. Okay. Now, so finally, g of x is equal to, we got maximum of the two functions in the first interval, x less than minus 1, x greater than 3, x minus 2 whole square when x less than minus 1 and x greater than 3. And the other one is minus 2x plus 7 when x values lies between minus 1 to 3. You know how to find g dash x. In each case, first derivative with respect. So x minus 2 whole square derivative with respect is 2 into x minus 2 when x less than minus 1 and x greater than 3. Minus 2x plus 7 derivative with respect to x is minus 2 constant derivative 0 when minus 1 less than x less than 3. Now using first derivative method, I am not finding second derivative method. Okay, because two subintervals given, two functions given. So clearly g dash x is negative when minus 1 less than x less than 3 and g dash x greater than 0 when x greater than 3. I already taken an example, x greater than 3. Let us take x is equal to 4. 2 into 4 minus 2. 2 into 4. G dash x greater than 0. So, therefore, g dash x less than 0 when x less than 3 and g dash x greater than 0 when x greater than 3. It is even if you take x less than minus 1 minus 2, this is negative in this case. When x greater than 3, this is becomes positive. Okay, g dash x is positive when x greater than 3. G dash x is negative already minus 2 when x less than 3. This is the case when x less than 3 and this is when x greater than 3. Using first derivative, that is we have whenever f dash x less than 0 for all x less than a and f dash x greater than 0 for all x greater than a. So then that function is maximum or minimum? Minimum using first derivative method. Therefore, g of x is minimum at x is equal to 3 using first derivative method. from maxima comma minima. Okay, I will show the diagram. See, x-axis, y-axis. Let us take a curve. This is the corresponding point P. The corresponding x value say A. This is the thing. So this is the curve. F of x. When x less than A, if I take the tangent at left side part of the curve, that is when all values of x less than A, that slope of the tangent is greater than 0. Slope of that line makes an angle, obtuse angle, that is greater than 90 degrees with x-axis. So that slope is negative. So if I take the tangent at any point on the left hand side of this curve, that is for all values of x less than A, at any point on the curve, the slope of the tangent makes an angle greater than 90 degrees with x-axis, so that tan theta is negative. That is, slope is negative. Okay. So I can draw at this point and at this point, the two tangents. This is the tangent and this is the tangent. Okay, so this tangent slope is f dash x less than 0, and this tangent slope is f dash x greater than 0. So this tangent, which is a line, makes an angle theta. If you extend this line with a positive x-axis, makes an angle theta which is less than 90 degrees, acute angle. If we extend this straight line tangent to touch the x-axis, which makes an angle more than 90 degrees. Am I correct or not? When theta is greater than 90 degrees, tan theta, which is the slope of the line, so tan theta is second quadrant is negative. More than 90 degrees means that theta lies in second quadrant. When theta is less than 90 means that theta lies in first quadrant. In first quadrant, tan theta is positive. Tan theta is nothing but slope of the line, which is nothing but f dash x also. Okay, so at this point, we will be getting minimum or not. That is the minimum. So this is minimum at x is equal to 3. Okay, so therefore the minimum, they are asking minimum or not. Value attained by the function g of x is where it attained, that means at what value of x it is having minimum at x equal to 3. So the minimum value is g of 3. How do you get g of 3? In g of x, what is g of x? It is given maximum. There you put x equal to 3. So that is nothing but maximum of 3 minus 2 whole square, comma, minus 23 means minus 6 plus 7. So which is nothing but maximum of 1, comma, 1 is equal to 1. So the answer is 1. For this function attaining at x equal to 3 maximum, the function g of x attains the minimum value at x equal to 3. So g of 3 is the minimum value and is given by 1. So the answer is 1. This is the end of the question.